Okay, kids, in this video, we are going to talk about area, measurements, and the decomposing of shapes as it relates to KNEX, okay? So what we're going to do is we're going to start off with a little bit of discussion about the metric system. These notes are kind of important, so you're going to want to write them down, okay? And we will be using the metric system. The metric system, okay, and the reason we're using it is because it's a little bit more accurate for our purposes, all right? And we will measure to the nearest half centimeter, and we're doing that for accuracy purposes. So you might want to measure, when we talk about measuring with KNEX, make a note that we are measuring to the nearest half centimeter for accuracy purposes. Also, what you want to remember is that 1 centimeter equals 10 millimeters. So if we look down here, you'll see that we have 1 centimeter, which means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little tiny millimeters in every centimeter. 1 centimeter equals 10 millimeters. If we were to come to this point right here, we would have 1 and 5 millimeters, which would actually be 1.5 centimeters, okay? Because we always go to the nearest tenth when we're measuring with centimeters and millimeters combined, or we convert them all to millimeters, okay? If we came to this point right here, okay, this would be 5 and 2/10 of a centimeter, okay? 5 and 2/10 of a centimeter. All right, now, so let's go on to the next slide and actually do some measuring. Okay, if we take our ruler and we measure the distance from here to there, remember that this is a wear-away zone on our ruler, and we have to start the ruler not here, but actually where our units start. So if we measure, we see that we have 1, 2, 3 full centimeters, so that measurement would be 3 centimeters. If we take our ruler and we measure over here, we line up starting with our first unit, we see that the measurement goes all the way up to 4 and then 1, 2, 3, 4, 5 millimeters. So this would be 4.5 centimeters, okay? Or this 0.5 means you have 5/10 of a centimeter, or if we wrote it as millimeters, it would be 5 millimeters or 45 millimeters. But that's how we would read using the ruler. Now, many times you need to adjust your accuracy for the situation. This is an important concept to know, that many times you need to adjust your accuracy for a situation. So you're going to want to make note of this, all right? Now, if this is going to be an example of one of those situations. So let's take and measure this line right here. When we measure this line, we see that we don't quite make it to 7 full centimeters. So we could be very, very precise and say that this is 6 full centimeters, and then 1, 2, 3, 4, 5, 6, 7, 8 millimeters, which would give us 6 8/10 of a centimeter. Or we could just round this up and say we have approximately 7 centimeters. Okay, if we measure this distance right here, we could say, wow, we have 1, 2, 3, 4, 5, 6, 7, 8 centimeters, and then 1, 2, 3, 4, approximately 3 or 4/10 of a centimeter. In this case, it's 4/10 of a centimeter is our interpretation. So we could actually round this to the nearest half and just say it's approximately 8 5/10 of a centimeter. So in this case, what we're doing is we're going to say we're going to round it to 8 5/10 of a centimeter versus rounding it down to 8. Okay, we're going to just round it to that. And that's a level of accuracy. So our accuracy could be, we could round this to 8, we could take it precisely to 8 4/10, or we could round it to 8 5/10 to the nearest half centimeter, which is what we did. Okay? Now we're going to go on and we're going to talk about a few other things. When we find the area of rectangles and squares, we use the following formula. And the formula we use is one you're familiar with, which is area is equal to length times width. And we have the area here, and we have length times width. And so our formula for finding the area of rectangles and squares is length times width. An interesting thing here to remember is that this is the foundation formula for finding the area of pretty much all polygons. And it is the foundation for other measurement formulas as well. So just this simple formula helps us find the area of many, many shapes, especially when we're decomposing shapes. All right, so when you record the area of an object, okay, this is another important piece of information. When you record the area of an object, use the following notation, okay? Use the following notation. You want to make sure that if you have 5 centimeters, you write it as 5 centimeters squared. Okay, this little 2 means 5 square centimeters. That's what the little 2 means, all right, as an exponent. Or you might say we have 45 square centimeters. It would be written as 45 cm2. All right, and that little 2 means that you're using a certain number to multiply itself by. In other words, you're using it twice, much the same way you would use exponents. All right, so let's move on to the next slide. Okay, here is how you would use this when it comes to finding the area of KNEX Shape. So you're going to do a little bit of a lab to find the area of a KNEX Shape, and here's how you would use all this previous information. How would you measure and determine the area of this shape? So here's our shape right here. We got a ruler out of the way. It's a rectangle. So we're going to use length times width. Why don't you pause the video and see if you could figure out how you would use this ruler to figure out the area of that shape. Once you've thought it through, start the video again and see if you are correct. All right, here we go. We are going to measure length first. And the measurement of this length, if we slide our ruler over, you'll see that it is approximately 8 5/10. In other words, we don't have an even edge here, but our red connectors seem to set the actual perimeter or size. So we're going to go from 1, 2, 3, 4, 5, 6, 7, 8, and almost a full half. So we have 8 5/10 of a centimeter. If we take our ruler and we turn it, we'll see that we have approximately 6 5/10 of a centimeter. So if we take it and we measure across, and we're going to go from the red connector edge to the red connector edge, we could easily have gone from the blue rod edge to the blue rod edge down here. And you'll notice that I'm not specifically going up to either a top or bottom, but I'm actually measuring somewhere down in here, okay? And so I'm approximately 6, and when I measure that, I'm going to go from the red edge to the red edge. I'm approximately 6.5 centimeters. If you measure down here, you might want to just go with 6, but in this case, I went with the red edge to red edge for my length, so I'm going to stick with the red edge to red edge because it's a blue rod and not much of a difference. But it's going to be 6 5/10 of a centimeter. When we multiply those together, 8 5/10 times 6 5/10, we get 55 25/100. Now watch how we record this in terms of area. Okay, when we record this in terms of area, we're going to say we have an area of approximately 55 square centimeters. We're going to actually round that 25/100 down to 55 because we kind of rounded this up. So we're going to kind of get rid of that 5 times 5 when we say the overall shape has an area of 55 square centimeters. Okay? So now we're going to go on and we're going to look at a square. Now, I've changed my ruler because the size of my image and everything, I needed a larger ruler to be more accurate in scale. But how would you determine the area of this shape? Why don't you pause the video, and with the ruler in place where it is, what do you think the area would be? Okay, unpause the video and see if you're right. Well, if we look at the ruler, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, approximately 11 centimeters. So our length is these 11 centimeters. Now, because we know this is a square, that all the sides are going to produce the same length. Now, notice that I didn't go to the red into the red this time. This time I measured from the yellow to the yellow. That's because this little red area right here isn't going to add that much and be that important to our overall area. So I know that even if I had to measure again just to be sure they didn't do something funky with the KNEX, I'd see that I have my width is approximately, let me adjust this a little bit so I'm right on my units there. My width is going to be approximately 11 also, okay? So when I do that, I can say that I'm looking at approximately 11 times 11, which is 121 square centimeters. And so I could say that the overall area of this square, and it's a little distorted because of the picture, is approximately 121 square centimeters. Okay? Now what we're going to do is we are going to talk about the important thing of decomposing shapes. Okay? We're going to talk about decomposing shapes. And this means, okay, this means the following. We are going to find a variety of smaller shapes inside a larger shape. Okay? So decomposing shapes means we are going to find a variety of smaller shapes inside larger shapes. These smaller shapes, okay, will be easier to find the area of. Okay? These smaller shapes will be easier to find the area of. All right? In other words, we might break down a larger shape into smaller shapes. All right? So we're going to now go into decomposing KNEX shapes, which means we are going to find a variety of smaller shapes inside a larger shape. These smaller shapes will be easier to find the area of. And then all we have to do is add the areas of the smaller shapes to get the overall area of the larger shape they came from. Okay? So there you go. And I typed this out so that it would be easier for you and, kind of have a bigger impact for you to understand the concepts and to remember them. Decomposing shapes means that we are going to find a variety of smaller shapes inside a larger shape. These smaller shapes will be easier to find the area of, and all you do is add the areas of the smaller shapes to get the overall area of the larger shape they came from. Okay, and so here we go. We're going to look at a couple example problems with our KNEX. Okay, how would you find the area of this shape? So how would you decompose this shape and then find the area of it? Why don't you pause the video and think it over, and then start the video when you're ready to see how it's done. Okay, here we go. Now, in this case, what we're going to do is we're actually going to take this shape and break it down into a smaller set of shapes. We're going to break it down into a small square and a rectangle. And what we're going to do is we're going to imagine actually having a square right here, and then imagine having a rectangle right through here. Okay? So that's what we're going to imagine. All right? So I'm just going to draw a line just so we can kind of like keep an eye on what it is we're doing here. All right? Now, the first thing I'm going to do is I'm going to measure my square. And when I measure my square, I'm going to measure the rods here because I have this funky corner here and I have a funky corner here. But I know that if I measure from here to here, I will get the length of one side. So if I measure from side to side, excuse me, you'll see that I have from here to here, I have 6 centimeters. So my one length will be 6 centimeters. And because it's a square, if I were to turn my ruler and actually do some measuring, I could measure down from the top and I'd see that I have 6 centimeters. So for my square, I have a 6 by 6 set of measurements, and I would multiply those and I would get an area inside that little square of 36 square centimeters. Okay? So then what I want to do is I want to measure the length and width of my rectangle. Okay, so I've decomposed my shape, and I'm going to measure the length of my rectangle, and I'm going to measure it from this yellow rod outside edge to white rod outside edge. And I'm going to do it on the inside of the rectangle because I've got these funky corners here that aren't going to be easy to measure, but I only want to really measure the rectangle, and these aren't really part of the rectangle. So the measurement here is going to be approximately 11 centimeters. So my rectangle has a length of approximately 11 centimeters. Now, if I take that and I turn my ruler and I measure its width, you'll see that, well, it's going to be the same as the squares approximately, and it's going to come out to about 6 because that was approximately the distance here. So we're beginning to make some connections. So we're going to multiply 11 times 6 to get the area of 66 square centimeters. And then what we'll do is we'll add this area plus this area because we decomposed this into a square. We decomposed this into a rectangle. We found the area of this square, the area of this rectangle, and now we're going to combine them for the overall area of 66 plus 36 is 102 square centimeters. So this whole shape right here has an area of approximately 102 square centimeters. All right, let's try with another example. How would you decompose this shape and then find the area of it? Why don't you pause the video and kind of imagine how you would find that area? When you're ready, start the video. All right, here we go. In this case, again, I always like to go with the square area first because squares are pretty easy to measure. We know that we only have to take one measurement. So if I come down here and I measure the length of my square, and again, I can just measure from the edge of the red rod to the edge of the blue rod because, you know, this little hanging out over here doesn't matter much. This right here isn't a nice corner to measurement, so I can just measure from red rod to blue rod, okay? And in this case, if I measure from red rod to blue rod, I have approximately 8 centimeters. And I know because it's a square that it'll be 8 by 8, a length of 8 and a width of 8. So my area for the square is 8 times 8, or 64 square centimeters. Now what I have to do is deal with this rectangle. Well, my rectangle right here, okay, up above, if you can imagine, I'll draw it out for you. My rectangle is up here, and I just have to pretty much come up with an estimated length and width of my rectangle. And in this case, if I measure across from the red rod to the blue rod, I'll get rid of those lines to make it more clear. I will have approximately 4 centimeters. Now, it's not really 4.5. I mean, I could hedge it one way or another, and if I get more accurate here, I might want to say, yeah, my rectangle has a length of approximately 4 centimeters. So in this case, I'm going to go to 4.5 centimeters. Now, if I was holding my ruler like this, somebody might measure it to 4. But in this case, I'm going to try and measure it as accurately as I can, and keeping my edge or my starting unit right here. And I'm going to say, well, you know, I guess I could round it down to 4, or I could round it exactly to 4.5. And in this case, I'm going to go with 4.5. So 4 5/10. So then I measure my overall. Tricky when I measure my length, but I'm going to measure, see where my green rod is. The edge of my green rod would be right here. So I'm going to kind of measure from somewhere right about in there and get as kind of accurate as I can to the edge of my green rod up here. And in that case, I'm going to say, well, you know what, that, if I measure it, you know, it's probably going to be close to 8, somewhere in there. Because again, you know, when I measured my square, I went from the outside edge of the rod to the outside edge. So I could actually say, well, maybe I'd be better off measuring from here to the outside edge. So this is where we learn to adapt our estimation and accuracy. So in this case, I'd have the upper rectangle. I would have approximately 36 square centimeters there, and then I would add these two measurements for a total of approximately 100 square centimeters. Hopefully, okay, so hopefully now you know how to decompose shapes in order to find the area of them. Okay, so for simple squares and rectangles, it's length times width. Sometimes you have to decompose shapes, which means that you take the shape and make it into smaller shapes, which are easier to find the area, and then you add those amounts together in order to get what it is you need for the approximate area of the overall shape. All right? So anyways, if you have further questions on this concept or these processes, you can see your teacher.